Hello, welcome to my channel for what it is. My name's Jeff. Now, what's the reason I'm starting this channel on YouTube? I guess for posterity, you'll have something recorded. Two, maybe impart some knowledge. I learned from a wise man many years ago that you don't have to know everything. All you have to know is how to find it. And that will do you good stead. Now, I am delving into the world of 3D. Fun, wow. Now, most things that I do is for a purpose. When I buy machinery or do anything, there's a purpose in mind. There's a reason that needs to get done. Now, how did my journey get here? I'm an electrician, and I'm in the electrical world. I'm involved in a business that requires electrical knowledge, and that's where I come in. I do consulting work for that company. Now, a while back, because of their product line requiring some changes, they needed a solution to a situation, and we were able to come up with a scenario which required some equipment and expertise and knowledge. Well, when it come to that, being that I had researched the necessary situation that we're doing now, not realizing what I was getting into, and so it was a big learning curve. And thankfully, over the years, I've learned a thing called patience, because a lot of times you lose patience. Perfectionists that are hard workers, usually the ones that lose patience the easiest, because they're trying to get something done in the best way that in their mind, and sometimes it just doesn't go together the way you're looking to put it together. But you'll have to learn to walk away, cool down, and come back at it, and you might have a different view, and you might go, oh, there it is, that's what I've been looking for. Doggone screw. Oh yeah, the screwdriver was in my back pocket. Stuff like that, So what that did is got myself involved in laser engraving, 304 stainless steel. So I had to go out there and locate the technology. Once I had to do the research, and I had to do it on a fiber laser, because doing research to properly laser engrave good permanent markings in stainless steel, you needed what was called a fiber laser. A diode laser would not cut it. A CO2 laser probably wouldn't cut it either. But fiber lasers are meant for metal, basically. Okay, without getting too in depth there. And big learning curve. I had to learn a program called EasyCAD, and that's basically the program that takes your generated graphics, converts it into what the machine sees, okay? And being that there's the only moving parts in the whole system is inside this they call it a galvo head, okay? That's the only place where the moving parts are for sending the laser beam to the surface and doing its thing. Now, I've had to learn a lot. It's been a year and a half now since I began this journey. And sourcing out the machine, I went to Alibaba because I was looking at some of the prices and went, wow. But in doing so, it took 4 months for the machine to get to me, for me to be able to start playing with it. So, but in that time, I was able to do more research, because I had already researched the laser that I needed, which is a JPT, which allows me much more of a frequency level. It's got good power. I looked at how much power I needed, and this is a 60-watt machine. Didn't really need to go much further than that, because I wasn't going to get into cutting, although I'm not going to say that This machine here would not cut through this eventually. This stuff here it might take a while, but probably enough power there to do that. Anyway, so I learned and I learned about the temperature of the metal has to be constant. I learned that, especially in the winter climes, the bed. Okay, even though I keep my little hut here at in the evenings, I keep it at 54 in the winter, and I bump it up 10 degrees when I'm inside here. That way, it keeps down on the gas bill. But I was finding that the markings I was getting, it wasn't being consistent throughout the year. So I found that number one, it was my metal plates that we were using. Okay, so I consistently have them when I deburr them and everything. When I get them, they're kind of raw. I have to deburr them, and then from there, clean them up, and then take them into the house to let them warm up to room temperature. Okay, which is 70 degrees, but I was coming out to a cold bed, which that kind of defeated the purpose, right? So then what I did do is I took the bed and I bought a 20-watt reptile pad, and I put it on, and as you can see there, I keep the bed, it's set for 70 degrees, but it fluctuates in between 68 and 70, but that's pretty consistent. Okay, so I had to, so that's a year and a half of messing around to get to the point where, that's where this machine here basically is a purpose machine. Okay, I don't do much other. If someone wants me to put something on one of our plates, I can do that for them because the machine's set up for that. Right now, the head is 3 millimeters positive out of focus to be able to get the effects I need on the stainless steel. Okay, and I don't want to mess with those settings because if you take your carriage or your tower and you up and down. I have one size lens that I keep in there. I have other sizes of lens that came with the machine, but will I ever use them? Who knows? Maybe if I get a second machine to play with, that's when I do that. Anyway, so that was a huge learning curve on that end of it, okay? And I'm going to be taking all this knowledge, okay, and frustration and whatnot, because I know there's settings galore. You have to play with stuff until you get the right settings for the machine. And so now this thing is dialed in for this material and everything, so it's dialed in, and I don't see any difference when it comes to 3D printing. Now the other thing here is I have to have ventilation, so I put in a ventilation system. I have it there. I have a shut off up there, and I also have here so that it comes up, and I have vents in my ceiling, so when I'm doing any welding or anything in here, or just have general whatever, I can shut this off over here, and then open up these vents, and then suck the general air out of the hut. But right now I don't want to do that because you got to heat it. You gotta heat that air, and then I just run out. Those are two 6-inch lines. I go up to an 8-inch line. I have an Inkbird 8-inch fan up there, okay, and it exhausted outside with the controller sitting right there, 8-speed controller. So does a great job. I mean, when you got it on at that top speed, wow! I mean, you're pulling. You can bring the temperature down in this room in no time flat. So it looks like my print is done. Googly googly. So that's my menagerie. I'm still finishing up the electrical in here. Yes, I'm an electrician. So yes, and that is not a good idea, but it's temporary for now until I get my other receptacle over there, and then the receptacle. There's gonna be a receptacle up there in that box to be able to plug in my switch from my router in the house, which is a PoE switch, which runs my 2 outdoor security cameras. I also run a B-Link, a little B-Link computer. Those things are great. I got one here, one in the house. They're great. Check them out. I just find if you don't need any peripheral, USB, HDMI, and you know, your Ethernet. It's hooked to the Ethernet. It has Wi-Fi. It's got Bluetooth in it. It's just, I mean, I use it for a Wi-Fi hotspot out here for this phone I'm recording on. A great little number. So anyway, so I'll get that all buttoned up. So that's kind of what got me into, where I'm not going to say got me into proper English here. Proper English, Jeff. Got me into looking at 3D printing. And is it a necessity? In a way, yes. Because, you know, you always go, I can make that if I had the right machine. Well, you know what? Everything's a hobby, okay? Once you know, if you're in business, sometimes that, you know, you're doing a side job, that's a hobby, okay? And hobbies can, you know, they can generate a little bit, maybe generate enough to get back the money you put into it, which would be kind of cool. So anyway, what did I look into? I researched it. And I found everybody saying, you know, if you're getting into 3D printing the first time, don't go overboard and buy a great big fat machine, you know, costing you $1,000 or whatever. So I went, okay, let's start looking at machines. So I start looking at machines. Okay, this machine, that machine, blah, 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 attributes, bad thing, whatever. And I found, just like my fiber laser, there's tons of clones out there. So you got to find the right clone, because clones are usually less expensive. So I settled with an Elegoo Neptune 4. And I didn't buy the Pro, mainly due to the fact that it had a dual heating bed. Okay, let's do this here. It had a dual heating bed, and I found that there's just too many electrical moving parts. You had a heater in the center and a heater on the outside. Well, if those two heaters didn't coincide properly, so that's one reason I went with the Neptune 4. That was one difference. Okay, there's another difference, was some kind of a card slot, which I don't care about, because I'm going to be using Ethernet anyway. And they say it doesn't have Wi-Fi. I don't care. I like Ethernet. I like the hard connection, because Wi-Fi, I get a little bit of interference, you know, and you know, just don't need it. Okay, don't need that hassle. So I settled with the Elegoo Neptune 4. Being I'm here in good old Canada, looking it up and buying it up here, I'd be closer to $500. So I just went on to Elegoo's site. It was $249 US. By the time of conversion, got it shipped up here, and you can take it from there. And what that's going to allow me to do, and what I am going to do, is I'm going to be eventually replacing, and I've already got the parts ordered. Don't know when they're going to get here. I'm replacing the X, the Z, and the Y-axis rails. I'm going to be putting linear rails on there, just to take out all this whatever chatter there could be, the wear on these rubber wheels, okay, and whatnot. Just take away those things that I've heard so many horror stories about, people having Z banding, I guess it is, and it could be attributed to, you know, these the bent rails. I'm also going to be replacing these nuts here with a nut that allows movement at the same time. It's a backlash nut, so I'm going to be putting those in. So, and then also, I'm going to, even though it's a smaller machine, I'm still going to put the braces in to make sure that this thing is as sturdy as it possibly can be. Okay, so there's tons of videos out there that show you how to put this together. In another half hour or so, I'm going to be doing that, bringing up those videos, and I'm going to start pausing and putting this thing together, and hopefully learning as I go. Now, the other thing is, once again, buy what you can afford. If you can afford one of those really fancy schmancy machines that give you 4 colors or whatever, go for it. You know, there's all kinds of stuff out there that you can automate these things. You know, there's automatic filament changers that you can put on, and they have automatic. Seen one with an automatic, took nozzles out and put it in for. It was just wild, the stuff that they've made for these smaller machines. But anyway, so I just want to make sure that the machine is stiff and travel is good and smooth and true. Okay, and then from there, work out the bugs, because I know, you gotta remember, This thing here is, once again, nothing more than a low-end little robot. It's a 3 gantry system. Okay, just because the gantries aren't connected to each other in the way they are, these two are. You got your X and your Z together. So literally, you could modify something like this and put you could modify it and do spot like miniature spot welding with this thing. Okay, because really, when it comes down to it, all you're doing, same as the fiber laser, you're taking a file you've generated, okay, so that you see the image you want to see. You put that into a program that is able to modify it so that it gives it all its parameters, okay, for the printer, I guess, your machine. It's a printer, okay, which sends it to another program, okay, which is an interface for the actual program, which is the machine, which is on the machine, to be able to take that because it's turned into a code the machine can see, machine code basically. And I guess in this 3D world of these printers, it's called G code. So you've got your programs, then you've got your slicer, then you've got your interface, which helps you set the settings for the program that does the actual firing the code to your servos and all that kind of lovely stuff, turning your heat on, filament feed, all that kind of stuff. Yeah, I'm starting to learn the terminology. Absolutely. So once again, I have Inkscape, so I can do rudimentary 2D in there, kind of get a concept on the 3D side. Then I can throw that into FreeCAD, which is another open source CAD program, which I could probably export out of Inkscape an STL file, I guess. Now, whether it would work and take it right to the slicer, I don't know. I don't think I'd be able to do what you can do in FreeCAD on Inkscape. Pretty sure you can't, but who knows? I haven't delved that far into it. Because now, Purpose, FreeCAD, I'm starting to, having to learn that, even though I've dabbled in both for years. Once again, purpose. There's a purpose you need to be able to do this stuff. So, so from there, I'm going to go all kinds of slicers out there. You can do your research. I guess there's Cura, and what's the other one? There's another one, and then there's Prus or whatever. I can't remember. It's just there's just so many out there. So I come across this one called Orca. It's open source, and it seems to be a flavor of, just like Linux, a flavor of another root program. So I'm going to stick with it, learn it, and this machine has come with Clipper, I guess, instead of the other one, and I'm going to learn that, and I'm going to be using, I guess, the interfaces. There's generally three interfaces that work with Clipper, I guess, and one's fluid, another one is mainsail, and then there's a third one. I'm going to stick with mainsail from the research I did. The mainsail is really compatible with Clipper. So there's the interface there. There's the fan that gives more volume of air, I guess, for better cooling. So something else I got to learn. Wow, all the stuff, all the tools and everything in there and whatnot. So I'm gonna be putting this thing together this afternoon, and then I'm gonna go from there. So I will be putting up more videos, and it'll be concerning mainly this trials and tribulations. If I do run into something that I'm gonna see is gonna be a problem, I will record it and throw it up. If not, the next recording will probably be showing the bed here, the printer, actually doing some printing. Now, the other thing I'll be doing, I've learned about filament. Got to make sure your filament is dry and whatnot. You get into the other films like this ABS stuff and nylon. I guess you got to make sure the temperature around the is consistent. So you need a box. So eventually I am going to build a box for this thing anyway, just so that there's there isn't any extraneous air movement messing things up. No. Once again, the humidity, I've learned once again on my fiber laser, my humidity sensor, the humidity really affected everything as well. So I had to put in a humidifier in here, which is putting my back with all my tools in here. So I keep it at try and keep it at 45 percent humidity, and right now it's 63 in here, which is more than warm enough to fiddle fart around. And then, like I said, in the evenings I just put her down, and it doesn't take long for this place to warm up. So there you go. That's about it. So it's a Neptune 4, and hopefully this little ditty here will kind of help you make a choice once you've seen what I've gone through. So let's see what kind of frustration level can happen here. Okay, we'll talk to you all later. Thanks for watching.